Hello everybody, welcome back to my channel. This is Dr. Bobby Basu from Heritage Business School, Faculty of Operations Management and Operations Research. Today I am going to discuss on plant location and types of production system. Both the topics are very important in production management. As you know, production management is a function of management related to planning, coordinating and controlling the resources required for production to produce specified product by specified methods and by optimal utilization of resources. Now before we go to the topic, let's recapitulate few terms which are very important in production management. First is production system. It basically refers to the transformation process which converts the input raw materials into output finished goods. Second is production. By production we mean the quantity of output produced by a production system. Productivity basically refers to production per unit of factor of production. Now it basically refers to it's a measure of efficiency of a production system. There are two types of productivity, total productivity and partial productivity. Total productivity refers to productivity of a production system as measured in terms of all the inputs put together. So total productivity can be defined as output in a given period divided by all the inputs like labor, capital, materials, energy in the denominator. Now, since productivity is a ratio, we have to always keep in mind that output and inputs both are to be expressed in the same unit. What is partial productivity? Partial productivity is the productivity of a production system as measured in terms of a single input. So if we define partial productivity with respect to labor, then it is equals to output in a given period divided by labor used during that period, and both definitely output and input both are to be expressed in the same unit. Now there is a pertinent question comes to our mind, that is, what is the difference between operations management and production management? Operations management is often used along with production management, but there are 2 points of distinction between them. Production management is more used for a system where tangible goods are produced, whereas operations management is more frequently used where various inputs are transformed into intangible services. Thus, operations management covers service organizations such as banks, airlines, super bazaars, educational institutes, where some kind of services are provided to the customers. The second point of difference is that production management precedes operations management in the historical growth of the subject. Next, how the performance of a production or operations management is to be assessed. There are 3 criteria by which we can assess the performance of production or operations management system, and they are effectiveness, efficiency and customer satisfaction. Effectiveness is a measure of how close we are to our goals, whereas efficiency is a measure of output by input ratio. Now the difference between these two will be more clear with this example. Suppose a person is standing at point B and he wants to reach the point C. So there are 2 paths available to him. One is from B to C directly, or another path which is available to him is B to A and then from A to C. Now in both the cases, the person is able to reach his goal, that is C. C is his destination, and in both the cases, whatever path he follows, he is able to reach his destination, and so he is effective in reaching his goal. But if the person traverses BC, in that case he has to travel less amount of distance and hence it will take less amount of time. So the input given will be much lesser compared to the other path. So if the person traverses and reaches the point C by traveling the path through BC compared to BA and then to AC, in that case he will be more efficient. So the person who is traveling through BC will be more efficient compared to the person who, if he travels from B to A and then from A to C. So doing things right is a measure of effectiveness. If we do things right, then only we will be moving towards our goal. Whereas doing things rightly is a measure of efficiency. If we do things rightly, then we will be consuming less amount of resources. Wastage will be less and we will be more efficient. The third criteria which is of importance is customer satisfaction. Although we don't use this word, we talk about customer delight now. So if our customers are delighted, definitely as a production or the operation manager, our job is successful. We are successful at our jobs. Now coming to the topic of today, that is plant location. Plant location decisions concerns both manufacturing as well as service organizations. Why it is important, or what is the need for a good plant location? Plant location decisions, being strategic and non-repetitive, require detailed analysis of long-term consequences because of the following two reasons. First is, poor location of the plant can be constant source of higher cost, difficult marketing and transportation, dissatisfaction among the employees, suppliers and customers, frequent disturbances in production, and all this leads to competitive disadvantage to the company. And the second point, which is also very pertinent, is once a plant is set up at a particular location, it is practically immobile, and hence one should carry out economic survey before setting up a plant in order to optimize the production cost and thereby improving the overall effectiveness of the enterprise. Hence, plant location is a very, very important strategic decision that a company should take before setting up a plant. Now, what are the steps in selecting a location? Plant location studies are carried out in three phases. First is territory selection. This involves selection of overall area or region within the country, and this selection is based on certain factors like proximity to market, proximity to source of materials, climatic condition, availability of utilities like power, water, fuel, etc. So once the territory has been selected, then comes the community selection. In the community selection, it is based on the selection, it involves selection of a particular community or locality from within the selected region, and the basis for such selection can be availability of labor, labor attitude, service facilities, service requirements, etc. Definitely, location of nuclear power plant close to border area is undesirable for safety requirement. Hence, all these factors are to be considered while we select a particular community within a territory. Now, once the community has been selected, next comes the site selection. This involves selection of a particular site from within the selected community, and the basis for such selection can be cost of land, suitability of land, waste disposal, and then expansion potential, and also flood and drought experience in the last few years. So based on these factors, we select a particular site. Next, so the factors influencing the three phases of plant selection, that is territory factors, community factors and site factors, are all put together in a summary form in this particular chart. This is very important. The decision regarding plant location should not consider only tangible factors or economic factors like sales, revenue, costs, profit, and ROI, return on investment. But we should also give weightage to qualitative factors because they are also very important in selecting the site. Qualitative factors like community facility and community attitude are also to be taken into consideration when we go for site selection. Let's take an example. A small-scale industrial unit intends to select one of the three locations A, B, C. The data of both tangible and intangible factors collected by the location analyst is given below for three locations. The question is to select the best site. So as you can see, the figures are total investment in each of the three locations are given. Total sales figure in each of the three locations are also given. Expenses on raw materials, distribution, utility, salaries and wages. All these quantitative figures are given for the three locations. And we are also provided with two qualitative factors, community facility and community attitude. So as far as the qualitative factors are concerned with respect to community facility and community attitude, site A is the best, right? It's good for both community facility and community attitude, but site B is the worst. Okay, so this also we should keep in consideration when we go for site selection. We should not only consider the economic or the tangible figures. Let's go to the solution. As we know, rate of return in percentage is equals to total sales minus total expenses divided by total investment. So total investment and total sales figure are already there in the table in the question. We calculated the total expenses at each of the three locations. Total expenses is calculated by adding the expenses on raw materials, distribution, utility, salaries and wages, and this comes to be 2,10,000 for site A, 2,20,000 for site B and 2,50,000 for site C. Based on that, using our formula, the rate of return percentage is 52% in case of A, 54% in B and 40% in C. So although site B is advantageous as it gives the highest rate of return on investment, but due to poor quality factors in terms of community facility and community attitude, site A should be selected. I hope this is clear. Now, next come to the next topic of our discussion, that is types of production system. Now there are two types of production system. One is called intermittent production, another is called continuous production, and the types of production system that is to be chosen depends on the following aspects, right? So first is flow. Flow means ranging from a large number of possible sequences of activities to only one possible sequence. What does it mean? It will be more clear when we take into consideration the layout. So next point is layout. Layout may be process layout or product layout. In case of process layout, what happens? All the machines which are of same type are grouped together and the item or the inputs are to be routed through various processes to produce the output. So the flow is highly jumbled, right? But in case of product layout, all the machines are put in a particular sequence. All the dedicated machines are put in a sequence, and so the inputs traverses through all the machines to produce the outputs. So the flow here is unidirectional or single flow. That means in case of process layout, the flow is jumbled, and in case of product layout, the flow is single. Third is flexibility. Flexibility means in regards to allocation of work to equipment and worker. by any chance, if your one machine is not working in case of product layout, the entire production line will come to a halt. Or if a particular worker is not present on a particular workstation, then entire production may suffer. But in case of process layout, flexibility is high. Why? Because if any particular machine breaks down, or if any particular worker is absent, in that case it can be allocated to different equipment. The work can be allocated to different equipment or different worker. So flexibility is high with respect to process layout, but flexibility is low with respect to product layout. Fourth is variety of products. So in case of process layout, we have seen that variety of products is high, many, but in case of product layout, the variety of product is one or few, one, maybe two or three. So two or three, maybe maximum 2 or 3 products may be produced using the same product line, right? Fifth is capital investment. Capital investment may range from using lower cost general purpose equipment, as in case of process layout, to expensive specialized equipment, as in case of product layout. Variable cost ranging from a high unit cost to a low unit cost. Then comes the labor content and skill, which may range from high labor content with high skill to low labor content and low skill. So if you can remember, product layout in which all the entire job is divided in small tasks, and each task is given to a particular worker standing at a particular workstation. So here in case of product layout, the labor content is low and the skill requirement of the labor is also low. But in case of process layout, the workers are to be highly skilled, because he should have the knowledge in which route the inputs are to be passed through so as to produce the outputs. So in case of process layout, labor content and skill requirement is high, but in case of product layout, labor content and skill requirement is low. Finally is the volume. Volume ranges from a quantity of 1 to large scale mass production. In case of product layout, the volume produced is high. In case of process layout, volume produced is very low. It may be 1 to few, or it may be 1 to small number in batches. So based on this, we have got two types of production system. One is intermittent production system and second is continuous production system. This is what we have discussed. Has been put in a summary. In case of intermittent production system, the type of plant layout to be used is process layout. In case of continuous, it is product layout. So flow, large number possible sequence of activities is possible in case of process layout, and hence in case of intermittent production, the flow is highly jumbled. And in case of continuous production system, where product layout is followed, the flow is one possible sequence. Coming to nature of product, in case of intermittent production system, we produce customized product. In case of continuous production system, we produce standardized product. Capital investment is low in case of intermittent production system, as we use low cost general purpose equipments, but in case of continuous production system, the capital investment is high because we use expensive specialized and dedicated equipment. Labor content and skill, high labor content with high skill in case of process layout, because it is the workers who decide how to route the items or inputs through different machines to produce the outputs. But in case of continuous production system, the labor content is very low and the skill requirement is also very low, because the entire job is divided into small tasks based on division of labor. Flexibility is high, we have already discussed this, and in case of continuous production system, it's low. Quantity of products, a small quantity. In case of intermittent production system, and it's large quantity in case of continuous production system. Variety of products, wide range of products using intermittent production system, and we have few or one in case of continuous production system. Change in machine setup, since same machines are being used to produce a wide variety of products, so machine setup will be frequent. And in case of continuous production system, we manufacture only one product or maximum 2-3 products, so the setup changes are not frequent in case of continuous production system. Nature and size of orders, small quantity, non-repetitive, non-standard, and first in, first out. So this type of orders are produced in case of intermittent production system, whereas in case of continuous production system, we produce large quantity, repetitive, standardized outputs, and the products are produced and made to stock. So this differentiates intermittent production system from continuous production system. Next, intermittent production system is also of two types. It is classified into job shop production and batch production. Let's see what is job shop production. In job shop production, one or few units of a product are produced to customers' requirement within the given date and within the price fixed prior to the contract. So here we produce one or few units of a product. But the products are highly customized. Products are based on customers' requirement within the given date and within the price fixed prior to the contract. This will be easier for one to understand if we take the examples. Example of job shop productions are tailor shops, tailoring shops, cycle and vehicle repairing shops, job typing shops. Take the example of tailoring shops. Here the items or the products are highly customized, right? And the type of equipment used are general purpose equipment. It relies highly on the knowledge of the tailors to produce a wide variety of products. And the job shops are low in efficiency but high in flexibility, right? We can ask for any type or any design of garments which the tailor shops will be able to make for us. So job shop production means only few units of a customized products are produced using some general purpose equipment, where the knowledge of workers to produce the wide variety is very important, and hence job shops are low in efficiency but high in flexibility. So the characteristics of a job shop production are: it's jumble flow, high flexibility, many variety of products can be produced using low capital investment machines, variable cost is high, labor content and skill is also very high, and the volume of production is low. Next is batch production, which is also another type of intermittent production. A batch production is an intermittent production where a limited quantity of each type of product is produced or manufactured at a time. Now it is similar to job shop. Except that sequence of activities tends to be in a line and is less jumbled. Here one can identify the dominant flows. The activities while in line are disconnected from one another. So maybe a part of the product flow is in line and the other parts are disconnected from it. A batch process executes different production runs for different products. Now the disadvantage of this batch production is the setup time required to change from one product to another, but the advantage is that some flexibility in product mix can be achieved. So we can have wide variety of products using batch production. But since the machine has to be change or the setup time, the requirements for the setup time is the biggest disadvantage for batch production. So examples for batch production may be pharmaceuticals or manufacture of ready-made garments. So if you take the example of ready-made garments or pharmaceuticals, they follow batch productions. Characteristics of batch productions are disconnected flow with moderate flexibility, products are several, capital investment is moderate. I am saying moderate because with respect to job shop production, the capital investment is moderate. Variable cost is also moderate. Labor content and skill is moderate. Volume is moderate. So all this moderate are with respect to job shop production. Third, then we come to the continuous production. Continuous production is of two types. Now, continuous production system is the specialized manufacture of identical products on which the machinery and equipment is fully engaged. So we have got a dedicated line. All the machines and equipments in that dedicated line are used to produce that product only. The continuous production is normally associated with large quantities and with high rate of demand. So here we manufacture standard products, standardized products are produced. Hence the advantage of automatic production is taken. This system is classified as mass production and continuous flow production. So continuous production is of two types, mass production and continuous flow production. Let's see what a mass production is. A mass production is a continuous production where standardized products are produced in large scale and made to stock in warehouse awaiting sales. So standardized products are produced in large quantity. The mass production connects the activities and paces them, for example, with a conveyor belt. In case of mass production, we use special purpose machines connected in a particular sequence, and all the machines are dedicated to produce that particular product only. It connects the activities and paces them with the help of a conveyor belt. Here, since the entire job is divided into small tasks and each task is given to a particular worker at a particular workstation, so the skill requirement of the worker is low. It is high in efficiency because high volume of production is possible, but low in flexibility because we are able to produce one or few at the same time. If by any chance, if any machine breaks down or if a particular worker is not there at a particular work center, then the efficiency, then the production may suffer. So characteristics of mass production: flow is connected line, flexibility is low, products are few, capital investment is high, variable cost is low, labor content and skill is low again, and volume is high because we are producing standardized products with the assumption that products will be sold in the market. So standardized products are produced in volume and they are made to stock. Example of mass production can be automobile plant, refrigerator plant, where large quantity of standardized products are produced and made to stock. Another important type of continuous production is continuous flow production. The difference between mass and flow production is the type of product and its relation to the plant. In mass production, identical products are produced in large numbers. If the demand fails or ceases, the machinery and equipment after slight modification can be used for manufacturing products of similar nature. Note this very well. In case of mass production, if the demand fails or ceases, the machinery and equipment after slight modification can be used for manufacturing products of similar nature. But in case of continuous flow production, the plant and equipment is designed for a specified product only. Hence, if the demand fails for the product or ceases, the plant cannot be used for manufacturing other products. It is to be scrapped altogether. Good example of continuous flow production is cement factory, sugar factory, petroleum refineries. Okay, so the plant and equipments are designed for a specified product. Plant designed for a particular product cannot be used for manufacturing other products. Quantity tends to be measured in weight or volume. Example, refinery, cement factory. Here the quantity is measured in weight or in volume. Direct labor content is low, but the skilled labor is high. If you visit any continuous flow production, or if you visit any chemical plant, you will find that you will hardly find any workers there. What you will find are the process control rooms where engineers are sitting and they are regulating the temperature and pressure so that the process is under control. So here the labor content is low, but high skilled laborers are required. And you will not find any worker to touch the products. The products are continuously flowing through pipelines, and hence it is called continuous flow production. So characteristics of continuous flow productions are: flow is continuous, flexibility is very low. If the demand of that particular product ceases, that particular system cannot be used to manufacture any other product. Products which may be manufactured may be only one. A particular product may be produced using a continuous flow production. Capital investment is very high. Variable cost is very low. Volume is very, very high. Labor content and skill is low, but we need skilled overseers. Okay, so this completes our continuous flow production. Whatever we have learned in this production system, I have tried to put in terms of a summary figure. So if we plot production volume along y-axis and production variation along x-axis, something like this comes out. Flow production, that is continuous flow production, volume wise it will be very high, but product variety is limited, it's 1. Mass production volume also it's very high next to flow production, but you can produce maybe maximum 2 or 3 products using the same product line. So mass variety product variation is lesser than product variation is more than flow production. Next is the batch production, and finally is the job shop production, where the product variety is high but production volume is low. So with this we come to end of today's session.